Okay, so we're gonna solve an example of a differential equation. So let me choose this. So this is the equation we're gonna solve. 2x minus 1 dx plus 3y plus 7dy equals to 0. So we have basically 4 steps to solve this differential equation. First thing we need to do is uh, verify if this is an exact differential equation. So for an exact differential equation, we need to check if this part that we call m of xy and this other part n of xy, this guy, satisfies the property of being exact. That is, the derivative of n with respect to y equals the derivative of n with respect to x. On this case, the derivative of m with respect to y is 0 because there is no y over here, right? And over here, the derivative of n with respect to x is 0 because there is no x on here. So that's why 0 equals 0. Therefore, dm dy equals dn dx. Okay, so this is an exact differential equation. So the next step is to recall what it means to be an exact equation, or what does it mean to have a solution for an exact differential equation. So what it means is that we need to find an f, right, that satisfies these two properties. The derivative of f with respect to x is m, and the derivative of f with respect to y is n. So basically the differential of the function is the equation that we want. Okay, so basically uh, we are looking for a function f of xy equals c, such that when we find the differential of this equation, this is exactly the equation we are looking for. Okay, so with that in mind, we just choose one of these two equations. So let's choose df dx equals m, and in order to find f of xy, we just integrate with respect to x. If we integrate with respect to x, we will obtain n of xy dx, and that will be, of course, on the left will be f of xy because the integral with respect to x of df dx will be f of xy, plus on this side a constant. So in this, but we have a two variables function, so let's call it g of y, okay? Because I'm integrating with respect to x, but the function is a two variables function, okay? So that's my step 2. So I need to find a candidate for f, okay? So the candidate is given by that formula, okay? So I need to find this integral. So let's find it. So f of xy is the integral of m of xy, that is 2x minus 1 dx, plus g of y, right? So we have 2x squared divided by 2 minus x plus g of y. So that is my f of xy. So that is the end of the part 2. So I have found a candidate for f of xy. So my third step is to find g of y. So I need to find g of y, and for that I need to solve the derivative of f with respect to y equals n of xy. Okay, that's my third step. So this is first step. This is the first step. This is the second step. So let's put it until here. And this is my third step. So I need to find g of y solving this. So for one side, I have n of xy, n of xy. I wrote it here 3y plus 7. So this is 3y plus 7. And on the other side, I need to find the derivative of f with respect to y. But look at this one. This is my candidate for the solution. So I need to find the derivative of f with respect to y. So this part doesn't have any y, so this is derivative will be 0. But this one has derivative, so this will be g prime of y. So therefore, g of y will be 3y squared divided by 2 plus 7y. Okay? Therefore, my last step is write the solution in an implicit form. So the implicit form is f of xy equals x squared minus x plus g of y. G of y is 3y squared divided by 2 plus 7y. And we don't need to write the plus c over here, okay? Because as we said, we're looking for this f of xy equals to a constant, okay? So because this is the path that the particle is going to follow, so really write the solution in an implicit form means write it like that. So this will be the whole equation will be equals to a constant. Now that's my solution. Okay, so let me mark it like this. This is my solution. So so is this a solution? Well, let's verify my equation. So the derivative will my derivative on the right hand side has to be 0. So that will be 0 because look at here. I have a 0 over here, right? And the derivative with respect to x has to give me n. So that will give me 2x minus 1, and this is 0. And I got 2x minus 1. Now over here, my derivative with respect to y has to give me n of n of n of xy, right? So n. So in that case, will be 3y plus 7. And look at this, I'll get 3y plus 7 because the derivative of y will, of the derivative with respect to y of this is 0. So